Welcome to subtopics 2 and 3 of topic 1. In this video, I'm going to work through some problems with you, and we'll learn along the way. First up, what amount of oxygen in moles contains 1.8 times 10 to the 22 molecules? Well, first of all, here is a formula, which is a word in the language of chemistry. It describes one molecule. Okay, back to the problem. It's fairly straightforward, but I'd like to use it to illustrate how I was taught in university to solve my science problems. If we write out the units, molecules, molecules, and mole, and then we can cancel units like we've learned to cancel numbers in math. The molecules cancel out, and we have moles, which is what our answer is supposed to be. Number 2, how many hydrogen atoms are contained in 1 mole of ethanol? Well, if we look at the formula for ethanol, we'll see that there are 6 atoms of hydrogen in there. Here we just multiply by the number of things in a mole, and we get 3.6 times 10 to the 24. Number 3, first of all, here is a chemical equation. This is a sentence in the language of chemistry. The question is, how many moles of carbon dioxide are produced by the complete combustion of 58 grams of butane? Notice, and we're asked to provide an answer in moles. So we've got to do some conversion here. First up, we take our 58 grams of butane, multiply by the weight of 1 mole of butane. Grams cancel out, and we get the answer, 1 mole of butane. Now, we take our 1 mole of butane, multiply by the ratio of carbon dioxide to butane in the formula. Here's our 2 moles of butane on the left-hand side and 8 moles of carbon dioxide coming out on the right-hand side of the equation. And we copy that down here in our formula. Moles of butane cancel out, and we're left with an answer in the units moles of carbon dioxide. So we know we've done the right math. Number 4. On complete combustion, a sample of a hydrocarbon compound produces 1.5 moles of carbon dioxide and 2 moles of water. What is the molecular formula of this hydrocarbon? Now, remember, this is the generic formula for hydrocarbon. And here's the formula for combustion of a generic hydrocarbon. Notice that all the carbon in the hydrocarbon ends up in the carbon dioxide, and all the hydrogen ends up in the water. So, we can take those 2 moles of water, multiply by the ratio of 2 moles of hydrogen for every 1 mole of water, units cancel out, and we have our 4 moles of hydrogen. We can do the same thing with carbon, but here it's a direct 1-to-1 ratio. The 1.5 to 4 ratio means that the formula must be C3 to H8. Number 5. Which compound has the empirical formula with the greatest mass? Well, first up, we need to realize that these formulas as we've known them, are molecular formulas. These tell us the exact number of the various atoms inside a molecule, whereas these are what we call empirical formulas. They're the mathematically reduced portions of the molecular formula. So C2 to H6 reduces 1 to 3. C4H10 reduces to C2H5, and so on and so on. These are the empirical formulas. Now obviously, C2H5 has the greatest. Number 6. A hydrocarbon contains 90% by mass carbon. What is its empirical formula? Let's remember the general formula for hydrocarbons. And let's copy from your book, which explains a very similar problem, and I think pretty well. So I decided to copy this table and change the numbers to suit our problem. First of all, the mass per grams of carbon will be 90, and if we divide that by the molar mass of carbon, we get this number. Conversely, if we take hydrogen, we have a mass of 10, what's left over from 90, divide by the molar mass of hydrogen, and we get this number. We look at that ratio, the molar ratio between carbon and hydrogen. We find out it's 3 to 4, and there's our empirical formula for this hydrocarbon. Number 7. What expression gives the amount in mole of a substance if the mass is given in grams? This is pretty straightforward. It's N equals M over M, where N is the number of moles, M is the mass in grams, and capital M is the molar mass. Number 8. When this equation is balanced, what is the coefficient for oxygen? This is pretty straightforward, but let's work it together the first time. Imagine we have 1 mole of C2H2, then that would mean we need 2 moles of carbon dioxide and 1 mole of water. For the oxygen to balance all out, we need a fractional number, 2.5, and we want to avoid fractions when we're balancing equations. So let's try it again. How about 2 moles, 4 moles, 2 moles, and 5 moles of oxygen? Number 9. I'm going to leave this one for you to try as an exercise. Last, number 10. What is the amount in mole of carbon dioxide formed by the complete combustion of 3 moles of butane? And they're asking for an answer in moles of carbon dioxide. So we start with our 3 moles of butane, multiply by the ratio of moles of carbon dioxide to butane. Moles of butane cancel out. We get 12 moles of carbon dioxide. That's it. Thank you for watching.